Hello everyone, my name is Akib and I am back again with another interesting walkthrough video on day 19 task which revolves around game hacking. So Advent of Cyber is fun activity that starts from 1st December till 24th December, and each day we get to learn something new from some different cybersecurity subdomains. So today we are going to cover day 19 task. Let's start with the storyline. Glitch was keen on uncovering mere malware's deeds. Today he was sure he would find something neat. He knew the mayor had an office downtown where he kept his dirty laundry. The big old clown. He approached the side silently, not knowing the door was closed so untimely. At the front of the door, the smart lock awaited. Glitch smiled because he knew it would be subverted. But oh, big surprise, the lock was eerie. A game controlled it. Glitch almost went to eerie. If you're wondering how this came to be, Mayor Malware himself will explain it quickly. Technology gets broken every day, was his claim, but nobody knows how to hack a game. Will Glitch be able to pass through the door, or will he end up with zero to his score? Learning objectives. So in today's task, we will actually be understanding how a game's API works, how to interact with the game's API using Frida, and how to hack a game with the help of this particular tool. Okay, game hacking, even while penetration testing is becoming increasingly popular, game hacking only makes a small portion of large cybersecurity fields. With its 2023 revenue reaching approximately $184 billion, the game industry can easily attract attackers. They can do various malicious activities such as providing illegitimate ways to activate a game, providing bots to automate game actions, or misusing the game logic to simplify it. Therefore, hacking a game can be pretty complex since it requires different skills involving memory management, reverse engineering, and networking knowledge if the game runs online. Executable and libraries. Executable file of an application is generally understood as a standalone binary file containing the compiled code we need to run. While some applications contain all the code they need to run in an executable, many applications usually rely on external code in library files with SO extension, which stands for shared object. Library files are a collection of functions that many applications can reuse. Unlike applications, they can't be directly executed as they serve no purpose by themselves. For a library function to be run, an executable will need to call it. Just to give you an example, like this is the example, this is the executable, and this is the library, and the functions within the library cannot execute itself. It needs an application to call those functions to be executed. The main idea behind library is to pack commonly used functions as so developers don't need to re-implement them for every application they develop. For example, imagine we are developing a game that requires two numbers together. Since mathematical functions are so commonly used, we could implement a library called libmaths to handle all our math functions, one of which could be add function. This is the game that we want to use to add numbers, and instead of including all the code within the executable, we use some libraries to call those functions, and then the function within the libraries gets executed. The function would take two arguments, x and y, and return the sum of both numbers. Note that the application trusts the library to perform the requested operation correctly. From an attacker's standpoint, if we could somehow intercept the functions call from the executable to the library, we could alter the arguments sent or the return value. Now, this is just a simple example. If we as an attacker could intercept the request, we could manipulate the behavior, how the library would return the results. This would allow us to force the application to behave in strange ways. Hacking with Frida. So today's task revolves around using Frida to intercept the request from the game to the API, to the libraries, and see if we can manipulate that. Frida is a powerful instrumental tool that allows us to analyze, modify, and interact with running applications. How does it work? Now, this is when we run Frida, it has certain steps that we need to understand before moving forward. Frida creates a thread in a target process. That thread will execute some bootstrap code that allows the interaction. This interaction, known as the agent, permits the injection of JavaScript code, controlling the application's behavior in a real time. One of the most crucial functionalities of Frida is the interceptor. This functionality lets us modify or alter internal functions input or the output, or observe their behavior. In the example above, Frida would allow us to intercept and change the values of x and y that the library would receive on the fly. It would also allow us to change the return some value that is sent to the executable. So this is the example. This is the executable, and with Frida, we can intercept, monitor, and modify the input parameters coming into the library, and also the return result. Let's take a look at hypothetical example. In this example, a number is simply printing on the console. So this is the application, just simple example that is just printing on the screen. What we want to achieve is by replacing the value with an arbitrary number, let's say 1337. Let's say we want to intercept this, because this function will call some library and print out something. So what we can do, we can use Frida to modify that and return the result of our own, like we can change the output result to 1337. Before proceeding, what we will do, the step number one, we will run Frida trace for the first time. So it creates handlers for each library functions used by the game. By editing the handler files, we can tell Frida what to do with the intercepted values of the function. To have Frida create the handle files, we could run the following command. So this is the Frida command, and we are providing it the executable and asking it to intercept the libraries. So we will now see the handlers directory. Now when we run Frida, it will have this directory created. So this is something that we will see in a bit. This directory contains a JavaScript file for each function your applications call from the library. One such function will be called, say hello, and have the corresponding handler at this JavaScript file, allowing us to interact with the target application in a real time. We don't need to understand how this file does, what this file does yet. We will review this in a bit. Each handler will have two functions known as hook, since they are hooked into the function respectively before and after the call. So there are two functions that we need to look at. One is on enter. From the function, we are mainly interested in the argument variable being passed to the library. An array of the pointers to the parameters used by our target function. Pointer is just an address to the value. This actually points to the arguments that we are passing to the library. And the second one is on leave. Here we are interested in the return value variable, which will contain the pointer to the variable return. So this points to the return value from the library to our executable, and it looks something like this. So we have the on and enter. This is the function that has the argument and arguments passed, and then we have another on leave, which contains the return values. We have pointers and not just the variables, because if we change any value, it will have to be permanent. Otherwise, we will modify a copy of the value which will not be persistent. Returning to our objective, we want to see the parameter with 1337. To do so, we must replace the first arguments of the args array this points to the first argument within the array with the pointer to variable containing 1337. Frida has a function called pointer ptr that does exactly what we need. Allocate some space for a variable and return its pointer. We will need to log the value of the original argument, and we can use the function to integer 32 to convert that, which reads the value to that pointer. Now look at this code. um, the arguments being passed is actually 1, but what we are doing, we are actually replacing that argument with and pointing it to 1337. So this is how we will actually be intercepting and manipulating the result to display 1337. So this is just an example. Now that we better understand how Frida works, what are its capabilities, we can return to Frida trace. We have already seen that it generates the JavaScript to hook a specific function automatically. But how does it know what functions needs to be hooked? The parameter I tells Frida which library to hook, and it will filter using the wildcard, tracing all the functions in all the libraries loaded. Okay, before moving forward, let's click on the start button, and it will take around 5 to 7 minutes to load the machine properly, and then after that we can start. Right, machine is loaded, and what we will do, we'll move that to a full screen and move that. Okay, so this is the lab is running, and let's start with the practical. Okay, this game actually has three simple challenges. The first challenge is the Frostbitten OTP. We can start the game. So in the lab, we have the game, and our task is to run the game, observe its behavior, intercept the request that it is sending to the library, and try to manipulate that in such a way that we can hack the behavior. We can hack into doing asking it to do something that it is not intended to. So let's first copy this, and let's run our game for the first time. Open the terminal and run this command, and let's observe the game. Okay. So this is the game. We have the character, and we are moving it with the arrows, and we can use space, interact with the penguin. So this is the penguin, and what it's saying, welcome to try unlock me, the only game-based lock in the world. Game, aren't smart locks good enough? The mayor fears any lock then that's smarter than him. Wanna know how it works? No, really. Nice, let me explain it to you. To open this door, you will need to prove you are a mere malware or our patent pending three-factor authentication system via our three-factor authentication system. Something you know, something you own, and something you are. What did you know that from? You're funny. Okay. The first factor is that the random number thing that the mayor has. You mean the OTP? Oh yes, the mayor mentioned something, that the frostbitten OTP. Do you have it? Okay, over here it seems we have to enter something. Okay, wrong number. You don't know. You don't look like mere malware to me. This is the behavior, the normal behavior of the game. It asks for the username, for the OTP, and if we enter correctly, it will let us go to the next stage. Otherwise, it will not let us go. Okay, so this is the game. We have explored the game in a bit, and we see that it is the penguin is asking for the pin. Okay, next step, terminate the game instance and execute the following Frida command to intercept all the functions in the libaoc game.so library where some of the game logic is present. So let me copy that, Let me close this and let's run this. Okay, before running, why, like, what's this library? So just for a better understanding, if we run this command and like this is the command that that points to all the libraries that this executable will require when it runs. So these are all the shared objects or the shared libraries that it points to or it needs during the execution. So this is the one that we are currently pointing to. Okay, let's run this again using Frida and see what happens. Okay, the game is loaded and this is running in the background. So let's run the game again, interact with it, and see how it works. Okay, it is asking for the same message, showing the same message, and it is asking for the OTP now. Okay, as soon as this function pops up, we get actually the function that is responsible for providing the OTP or processing the OTP. So if we run something, it will provide us the error, but the thing is we actually got to know the function that it called for the OTP. Okay, perfect. Now revisit the npc non-player character. We can trigger the OTP function on the console displayed as this. Okay, we have done that. Notice the output. This indicates that the set OTP function is called during the MPC interaction. You can try intercepting it. We were trying to intercept the request coming from the game, and we have intercepted that, and we know that this is the function that we actually need. Now let's open another terminal, and what we will do, this is let me go to ls. We have a folder created called handles, and this is the library that our game interacted with, and within that um, file we see that it contains three functions with which are JavaScript files, and Frida has actually created JavaScript files for each corresponding function. All right, what's next? Okay, we can now, next is to open this in Visual Code. How we can do that? Just run the code command and it will run the Visual Code in within this folder. All right, so what's next? Okay, we will see that we have Visual Code open. Let me Okay, Visual Code is opening. It's taking some time, so let's move on to the next. At this point, we should be able to select, like, within the Visual Code, we will see three files, and this is the file we actually need to solve to interact with and to understand this particular challenge. So this is the code. It contains three JavaScript files, and as we know, as we understand, from here, this is the code, the JavaScript code that we actually need. And we already have covered, like, we will have two hooks, on enter and on leave. Okay, this is the log. It is logging the OTP. All right, let's see next. So at this point we should be able to select this JavaScript file with the hook defined. The I at the end of set OTP function indicates that an integer will be passed. An integer will be passed as a parameter. It will likely set the OTP by passing it as the first argument. To get the parameter value, we can use the log function specifying the first element of the array args on the on enter function. So what we need to do, we can use the log functionality, log function, or the log command to actually view what kind of OTP is being passed to this particular function. So let's copy this and paste it over here, and save. And this is the kind of code our code will look like. So what we can do, we can interact with the program again and see if the parameter is logged in the terminal. So okay, fair enough. Let's interact with with that again and see we actually got the parameter. Okay, let's see if okay, this is the prompt. Let's enter the code 681063 because it's randomly created, so you may have different results. Let's enter and see we got our first password. Try hack me one tough password, very tough. So it can't be copied, so what I will do, I will we can use that to answer the first question. Okay, let me try. Okay, let's try the password here. Okay, so we got the first answer right. All right. So this was it. So one of the learning objective was that we have the game and we are interacting with it, and we are using Frida to intercept the request and manipulate it and asking it to display the parameter that it is being passed to the function or the library. Okay, let's move on to the next task. Try Unlock Me, the wish list for billionaires. Exploring the new stage, you will find another penguin with the costly item called Ring of Pass. The game lets you earn coin by using the old PC on the field, but getting 1 billion coins that may sound tedious. You can again use Frida to intercept the function in charge of purchasing the item. This game is a bit more tricky than the previous one because the function buy item displayed as this has three I parameters. Um, I letters after its name to indicate that it has three integer parameters. We can log these values using the log function for each parameter by trying something trying to buy something. Now these points to all the three parameters that are passed through the function. So let's try it out. So let's move on. Let's go through interact with the game. And okay, this is the PC that we can earn coins. Like this is how we earn coins. Okay, let's interact with this penguin. Let's press space and see you are now verified to be at least one third of a mere malware. Congratulations. The second authentication factor is called a wish list for millionaires. Sounds shady. How does that even work? I'll be silly to tell you this could compromise the whole system. Or at least you're more security aware than the last guy. Am I? Alright, I'll explain it just this once cause I like you. Mere malware is the only one in Wereville with a super ultra mega premium extra hyper plus card plan. This means he's the only one who could buy the coveted flag 2 item from the store. Okay, does he pay 1 billion coin every time he needs to open the door? He does, but then refunds the product. I must be rich by now, but if not for the cheap mare. But hey, if you have a cash issue, you can always mine some coins from the old PC. But see, it will take time, so it's a tedious process. Is there anything you would want to buy? We have three items to buy from. Like right now, we have three coins, and but we need the flag, which requires 1 billion um, coins. So how about I press 3? Okay. Um, see, we get the function gets log the function that is actually responsible for this kind of activity. Okay, this is checking the credit card, and you don't have enough money. Use the PC to get more coins. So this is the function that we need to check next. Right, let's move on to this function. And what it does, it again it takes the arguments and then whatever that is, it returns something. So what we need to do, we need to log the parameters that are passed to this particular function. Let's copy that and move that over. Okay, what I will do, I will paste these commands here. Not here, rather within the function. Okay, let's save and let's interact with the game again, with the penguin again. Okay, all right. I'll press 3 again and see we get the three parameters. So there, these are the three parameters, and if we understand, if we interact with it, this looks like the third is actually pointing to the third item. 1 billion actually points to the coin that is required, and 3 is actually showing the coin that I have. All right, fair enough. Let's see. Our JavaScript file should look like something like this, and we have done that. We should be able to log something similar. Yes, we have logged that. So we have the three parameters. Let's interact with that again, and now let's enter 1, and it's processing. See, it points to first actually points to the item number, and then its price, and then what we have, what points we have right now. All right. By simple inspection, we can determine that the first parameter is the item ID, the second is the price, and the third is the player's count. If you manipulate the price and set it as 0, we can buy any item that we want. Now that would be interesting if we are able to somehow manipulate the cost of the item that we want to purchase. Okay, let's try that. And what we are, for that, what we need to do, we need to um, point that to 0 pointer, and or 0 value. The second argument in the first index, 0 first index place should point to 0. Let's try it out. Okay, what I'm going to do, I am going to copy this and let's place it down below. We can remove the above three lines, but let's keep it that way. Okay, save it, and let's interact with this again. This actually is um, changing the value to 0. Let's interact with that again. Okay, I'll press 3. All right, perfect. So what we have done, we have manipulated the function to change that particular argument value to 0, and see, now we have got the flag. Let's move here to the next question. That is, what is the billionaire's item flag? Okay, this is the answer to the second question. Perfect. So we are left with the third challenge, that is naughty fingers nice hack. All right, so let's interact with another penguin. Let's move on. Perfect. All right, so this is the third penguin, and see, just one more factor to overcome the fully become to fully become mere malware. The last authentication factor is biometrics. At last, a normal authentication factor. So whose eyes do I need? Eyes, this is a punch based authentication system. Mere malware has a very specific way of punching the keywords that nobody can replace. And here we go again with the madness. Should I punch my keyboard then? Well, you can gently put your hands on the keyboard, no need to get violent. I was worried for a second. Now show me the keyboard. Please put your fist in the keyboard. All right. So what I am going to test out and see. I'm not getting anything, but the thing that I wanted to see was what function is responsible for this kind of activity, or what's happening in the backend. So this is the function we now need to examine and understand. So let's move on to the biometric this JavaScript file, and again it has two parts. One take care of the input arguments that we pass, and the other take care of the return values. All right, let's look at the task. The last stage is a bit more tricky because the output displayed by Frida is this. So it doesn't handle integers anymore. See, we don't have any I appended to this. It means it may not have any integers anymore, but strings, making it a bit more complex to debug. By selecting the JavaScript file, we can add the following line on the enter function, so that as we did before, to debug the content of the parameter. So what we are going to do, let's copy this line and paste it over here like this. Save, interact with that again. All right. Okay. Okay. We have actually got the parameter that is being passed to the game, but it doesn't make any sense. All right, we should be able to log something similar. The output does not seem very helpful. You may have to consider another way. You can log the return value of the function by adding the following log instruction in the onLeave function. So what we are going to do, let's try logging the return value. All right, let's try that. All right, over here, let's copy this, save, and then interact with the function again. Okay. Okay, it's saying the return value is 0. The return value is 0. Okay, let's interact. The return value is 0. What does this mean? We should see something similar to this, right? So this value returns 0, which may indicate that we are giving it a false result. Can we manipulate this return value to return something true? Can we trick the game into thinking that the biometric actually worked? The following instruction will set the value to true. So again, let's try this on the return value and see if it works. Let me change that to the return value. Okay, let's save and let's interact with that again. All right, the return value is this. Mere malware would have hit it with all his might. Who are you, imposter? You can't fool me. Oh, I am the malware. Yes, mere malware. Vote for me, please. All right. Oh, my bad. Welcome back, Mayor. We have missed you. Here's the flag. See, we got the flag. Right. Okay, let me try this. Okay, we can't copy. We have to actually write it down. That's perfect. We have got the answer, and that's it. So in today's task, we actually understood how game hacking works. We have the game and we see that as an executable. it interacts with various libraries. And we use tools like Frida to intercept those requests and the response and manipulate it to make it work as unintended, as it was not intended. So this was it. I hope it was an interesting task for you. I hope you learned something. There are still a couple of days left for in Advent of Cyber. So see you around. Take care.